Today, my topic is saving cost with outscaling on ACK. Here's the outline of this topic. First, we will talk about what is outscaling and why we need outscaling. Then, I will introduce how to do outscaling on ACK, give some example of typical scenes. Finally, I will show a HBA demo based on external metrics. In a recent search of over 900 tech leaders, we discovered that migration from IDC to public cloud and the private cloud is still accelerating. The adoption of cloud-native projects is more and more common. Kubernetes adoption is growing so fast. It is set to jump from 20% to 30%, 10-point increase by 2020. More than 56% of tech leaders care about how to improve resource utilization. Kubernetes is a standard cloud-native interface to help to accelerate IT infrastructure transformation. Saving cost is the top one factor to be considered. So, how to save cost on Kubernetes? Here's a chart about capacity planning and the burst resource usage. The yellow area is actual usage of your workload, and the red one is about capacity planning. When the red line is upper than the yellow area, that means you have enough resources to run workload. But the larger the spacing, the more you waste. When the yellow area is breaking through the red line, that means you don't have enough resources to run workload. Even the running workload may be affected of insufficient resource. Is there any ways to solve the conflicts? The answer is yes. Outscaling is the chosen one. On the right side, we have two real custom utilization charts on ACK. In the first chart, it weighs about 40% resource to guarantee the availability of the cluster. It's not good enough, but it's real in a lot of companies. The second chart is about resource utilization when used outscaling on ACK. The spacing between capacity planning and the burst resource usage is changing with each other and keep it at a low level. It helps to save about 30% of the cost. Outscaling is a game between capacity planning and burst resource usage. The better outscaling you did, the more cost you save. In the next section, I will introduce how to do outscaling on ACK. Here's the architecture of outscaling on ACK. We have two kinds of outscaling categories: application outscaling and resource outscaling. HPA is horizontal pod outscaling. You can use HPA to outscale pods based on metrics. VPA is vertical pod outscaling. It's not that popular, and we will not talk about it in details today. Cron HPA is another pod outscaling method. You can outscale pods based on cron type rules. It's useful when you can know resource usage trend in advance. In resource outscaling, we can outscale planned VM instance, bare metal instance, GPU instance, and a spot instance. And we also have a unique resource outscaling method called virtual node. You can regard virtual node as a giant node with unlimited resource. When pod scheduled to the virtual node, it will finally be created as a serverless pod without any node. HPA can outscale pod based on three kinds of metrics. CPU and memory are the most popular resource metrics. Custom metrics is about the user-defined metrics such as the number of people online in your application and so on. Typical external metrics is about cloud service such as QPS of the load balancer. So The richness of the matrix determines the strength of elastic scalability. In ACK, we provide all kinds of metrics based on multi-dimension monitoring architecture. We have 4 kinds of monitoring cloud service for different application types. SS is the log service. It can collect application log, control plane log, and the gateway log. ARMS is an APM cloud service for application performance tuning. You can use ARMS to virtualize the status of GVM and deep dive into your application tuning performance. AHAS is an architecture awareness cloud service. When you are using microservice to structure system, AHAS can help you to visualize the network flow between different microservices. Cloud Monitor is the traditional resource monitoring service. We also have managed Prometheus service as an alternative choice to the open source one. Based on the monitoring architecture, we transform all kinds of monitoring metrics into 3 categories. In resource metrics, we provide CPU, memory, network, and so on. In custom metrics, we not only provide the standard metrics interface, but also typical solution about how to use custom metrics with our application. In external metrics, we convert all kinds of metrics we collected, such as log and others, as oscillating factor. A comprehensive monitoring architecture makes HBA shiny. HBA is great, but not perfect. It may not scale up in time due to metrics scrapping. If you can know the resource utilization trend in advance, cron HBA would be a great supplement to the plain HBA. Cron HBA can also work with HBA. You can define the time-based scaling plan like cron rules. Cron HBA is a standard CID implement, so it's easy to use and to do integration with open system. Node autoscaling is a kind of resource autoscaling method. The class autoscaler would watch pods changes from API servers. When the pods are unscheduled because of insufficient resource, class autoscaler would choose a scaling group to provision new nodes for the cluster. When the new nodes join into the cluster, the unscheduled pod would be rescheduled to the new ones. In Alibaba Cloud, 500 Kubernetes nodes can be scaled up in 90 seconds. Virtual node is a very unique resource autoscaling method. It is serverless autoscaling rather than the plain one. You don't need to care about what is the node and how many resources I need. What you need is to bound the pod to the virtual node. You can use node selector and the tolerance to do that. When the pod is scheduled to the virtual node, it will finally create as a serverless ECI pod. This kind of autoscaling method is very useful when you do CI/CD, big data, and jobs. It's fast, simple, and with low learning cost. In the next section, I will introduce some typical scenario. AI training with GPUs autoscaling is very common on ACK. When you create a TF job with GPU request, if the cluster cannot schedule the pod, class autoscaler will choose the best autoscaling group based on simulation of scheduling and the lowest cost. The GPU scaling group would provision a new GPU node with NVIDIA Container Runtime installed. One GPU card bound to a single pod is the most common way, but sometimes it's not the best way because of the low resource utilization. We support GPU share scheduling and autoscaling. You can use GPU share feature to save cost. Multi-pods share the GPU mem of one GPU card. Isolation between pods is also supported. And now it is demo time. In this showcase, I will introduce a real user scenario. Ingress is the most popular gateway in Kubernetes. For most of online services, CPU is not always the best choice to do HPA. QPS may be a better one. So how to monitor QPS of your workload in Ingress Gateway and how to do autoscaling based on QPS. In the previous section, I introduced the log service can collect the log of Ingress Gateway. It can also do some analysis on the log, visualize the net flow, and convert them as metrics with the help of Alibaba Cloud Metrics Adapter. Finally, HBA can calculate the replica of the workload based on QPS. So let's start the demo. First of all, you need to create a Kubernetes cluster. We have a lot of kinds of Kubernetes cluster type, and standard managed cluster is the most popular one. This type of cluster fully manage your master node and to help you save computing resource. You only need to create worker nodes to run your business. Fill the blank to specify your cluster name, select region, Kubernetes version, container runtime, and choose which feature of VPC, select network plugin, port CIDR, service CIDR, and be careful if you want to manage your cluster on your own laptop, you need to choose public size external expose API server with EIP. And if your cluster is very big, you need to create advanced security group. And then you need to choose instance type of your worker instance and select the size of the cluster, operating system, keep high. If you want to use Ingress in your cluster, you need to check this box, install Ingress controller, and choose correct SLB network type. Typically, we will choose public network because if you choose internal network, you cannot access the Ingress controller from internet. And if you want to use Ingress as custom external metrics to do HPA, you need to check this box, enable log service, and create Ingress dashboard. Then confirm order. Check this box and create the cluster. When your cluster is running, you can jump into the Manage tab to get some basic information. You can get the API server public endpoint, API server internal endpoint, and access log project, Nginx Ingress SLB, and the important ones is you can get kubectconf here, public access kubectconf, internal access kubectconf. They are different. If you want to manage your cluster on your own laptop from internet, you can copy the content and paste it to the Kube folder. Create a file called config and paste the content. Then you can manage your cluster from your own laptop. Okay, let's create a deployment. Create from template, select the correct namespace, use the default deployment template, create, Then you can get a deployment here with 2 replicas. Let's create a service. Name the service as Nginx. Select class IP as service type. Select the backend we just created. And name the port. Okay, create. We will get a service called Nginx and create an Ingress service. Name Ingress service as Nginx. Select the domain. Fill the path. Choose the backend service. Okay. Choose port. Create. Okay. Then let's visit the website. Okay, it works. And we can find there is a link here called Ingress Overview. What is it? Let's click it here. That is Ingress dashboard. You can select a new time range, set auto refresh. You can view PV, UV, success rate, error rate, latency, and other useful information from this page. Then let's create an HPA based on QPS. Before we create the HPA, we need to install Alibaba Cloud Matrix Adapter. You can create Alibaba Cloud Matrix Adapter from application catalog. Click ACA Alibaba Cloud Matrix Adapter. And view the parameters. Typically, you don't need to change any parameters here. Just click create. And then you will get a deployment called ACK Alibaba Cloud Matrix Adapter in Kubernetes system namespace. And let's create an HPA. First, we can view the HPA YAML. You must use API version or scaling v2 beta 2 and use external type matrix. Fill the required parameters: SS project, SS logstore, and SS ingress root. The SS project is Kubernetes log class ID, and SS logstore is Nginx ingress. SS ingress root is namespace, service name, and service port. And the target value is 10. That means if every port has more than 10 QPS, then HPA controller will scale up new ports. Kubectl apply HPA.yaml. We can watch this HPA. Okay, and we can use AB to simulate a stress test. AB, we can cite request to a very big value and connection to 10. Copy the ingress endpoint. Copy the ingress endpoint. And can find the HPA is working. Current replica size is 4 and the file is desired. And if the stress is stopped, HPA controller will scale down later. Wait for a few minutes, we will find the department has scaled down to 2 replicas. And thank you for watching for this topic.
Hello everyone, I'm a security software engineer from Alibaba Cloud Container Service team. My name is Kwangda Hu. Today I'm glad to share the security solution on ACK. This is the agenda of the slides. The first part is about why container need security more. And in the second part, we will introduce what is the security architecture design on ACK. And then we will show the key security feature illustration. And in the end, let me show some demo. Okay, why we need container security? Based on the State of Container and the Kubernetes Security Report from Sandbox this year, in the past 3 years, there's more and more enterprise use container technology in their production environment. And we can see the security is the biggest concern in companies' container strategy. In the same time, the threat is everywhere. According to the statistics, there is more than 25 CVE vulnerabilities explored in the past 3 years. So based on the huge challenge and the customer requirements, in this part, let me introduce our solution architecture design. Based on the huge challenge, we propose our high-level security architecture. In the basic infrastructure security layer, we have the solid security feature provided from our private and public cloud platform. Based on that, we implement RAM integration authentication and the RBAC authorization and the auditing for Kubernetes API server and the ICE resource. And also, we provide an open source solution called kube2ram for the fine-grained RAM role in workload pod. In software supply chain layer, we support image signing, scanning, and secure distribution during workload building and deploying. In the runtime security layer, we have Sandbox container, which provide an independent kernel to enable enhancement security isolation. And then also we support runtime mounting and defense. This page is the component diagram of our security framework. We have access control, network security, and SSL certificate service in our infrastructure platform. And we integrated RAM and a third-party SSO solution for authentication. And there is a whole fine-grained RBAC authorization access control framework. Besides, we have security hardening on ACK nodes, and there are security management solutions for data encryption at rest. In runtime layer, we have security center for container runtime monitoring and the PSP support for pod security context admission control. Okay, this part is a feature illustration. Let me show some more details on our security features. The first feature is fine-grained access control. We support both access control on cloud resource in management layer and the Kubernetes cluster resource access control in data layer. The administration could easily authorize one RAM sub-account on console with our preset RAM class role template, and also we support customized class role and banding. Before the configuration finish, we will check the RAM authorization for cloud resource and auto-generate the RAM policy if management access control is not finished. For default configuration security, in the first step, we have hardened cluster control plane security based on CIS Kubernetes benchmark. And in second step, we will ensure system pod and controllers are configured using the best practice. And in the second step, we will also ensure there is no critical CVE vulnerabilities in system pod images. All of these security hardening validation were integrated into our daily scanning job. For auditing, we support different kinds of auditing, like API server auditing, Ingress traffic auditing, and the Kubernetes resource event auditing. The agent from SOS service will help us to collecting the log, show them in console, and provide the powerful searching abilities. In audit log, it can help the administrator to track operations performed by different users, which is an essential part of security maintenance operations. And in Ingress traffic auditing, we can find the inbound and outbound traffic and the statistics of PV and UV. In Event Center, we can find the key event for cluster DevOps, like the events of image pull failed and pod eviction and so on. We provide the cloud-native supply chain to deploy only trusted container in cloud. With the cloud-native supply chain, you can configure the validation policy to automatically block risky image to deploy. Besides, you can require image to be signed based on your own key during the deployment process. And then you can also enforce signature validation when deploying. Okay, for the DevSecOps scenario, in our container registry service, you can freely combine tasks such as image building, image security scanning, image synchronization, and image distribution in a single delivery chain. The cloud-native supply chain is fully observable and traceable. Compared with the Docker containers, Sandbox containers enable your applications to run on a lightweight virtual machine, which provides an independent kernel to enable enhanced security isolation. Sandbox containers are suitable for scenarios such as load isolation among multi-tenant and isolation of untrusted applications. In addition to enhanced security, Sandbox containers have little impact on performance, and it can offer the same user experience as Docker containers, such as the feature of logging and monitoring and elasticity. In container runtime, the runtime monitoring and defense is an important security feature. In Alibaba Cloud Security Center, it supports container risk detection and alerting, including the feature of malicious image startup detection, intrusion into containers, the container escape, high-risk operation alerting, and so on. In the picture, we show the alerting and isolation for Grabboard, which is the first ever minor cryptojacking worm found in image on Docker Hub. Security management is essential to enterprise container application on cloud. For the security management solution, we have ACA KMS plugin, which based on the Kubernetes encryption provider framework. User could encode security data at rest with customized key in KMS service. Besides, we provide ACK Security Manager, which help you to import, using, and synchronize the secret that managed by an external security management service. User can directly install it in our app catalog, and both of these two solutions is open source. You can find the code in GitHub. At the end, let me show some demo. Okay, let's begin the demo. I have logged into our Container Service Console with my primary account. The first demo is about the RBAC authorizations. In authorizations page, you can see we support both RAM user and RAM roles. In RAM roles tab, you can input the role name here, and our backend will automatically validate the input role's name. Back to the RAM user tab, you can choose all of the users or just one. I will choose a user and click Modify Permissions. This is the RBAC access control page. You can see there's already an existing permission bounding here, and we support 4 kinds of preset permissions. For the administrator permissions, it means the authorized user will have all permissions for all kinds of Kubernetes resource. And we also support customized permissions. You can create your own cluster role in target cluster, and it will show this in this pop menu. And you can select the target class role to bound on your sub-account. Okay, I will add a new bounding. First, select a target cluster. Then select a namespace. And select developer as the permission. Okay, the notice here means the selected user has not finished the RAM authorization on the target cluster. So we have to finish these 3 steps on page. First, I will copy this text and go to the RAM console. In the policy page, click the create policy and input the name. Here we should select the script mode and paste the text here. Okay, I have created a new policy. Go to the user page and search the target sub-account. Add permissions. In customer policies, search the policy I have created. Okay, we have finished the RAM configurations. Then go back to the container service page and click the submit. Now you can see we have finished the authorization. Okay, Let me verify the authorization. I have switched to a new browser with authorized sub-account. When I refresh the page, you can see the new authorized cluster show here. And I will test the permissions. Yes, we have not configured the node list permission, and it should not have the permissions to list the namespace. In the deployment page, it can only see the authorized default namespace. Okay, let's come into the second demo. It's about the binary authorization solution. Firstly, we should create a signing case in the KMS console. Firstly, we should choose the right region and create the key. Here, choose the RSA for the key spec and choose sign verify for the purpose and input the alias name. Here we have created some keys for this demo. Then we go to the container signature page in the Security Center console. Firstly, we should create a witness. Input the name and select the keys we just created. In the Security Policy tab, we should create a policy. Select the target cluster and the namespace image. The image would be verified by this witness. And then input a description. Okay, the policy is created successfully and we should enable it. Then we go to the container registry page. Firstly, we need to create an enterprise instance. Please note the specific here should choose advanced. Here we use here I already create an instance today, and we will reuse it in the instance page. I have created the repository namespace. You can find the image signature here. Create a signature rule. Choose RSA PSS shard and select the witness. Then select the scope. All images in this namespace would be automatically signed by this rule. In the repository page, if the picture here is green color, it means the signature is enabled. Okay, let's back into our container service console. Select the target cluster. And we try to log in to it. Okay. Firstly, we can find the Kubernetes validation webhook has installed successfully, and then we try to deploy a deployment without signed image. As you can see, the deployment is denied because the image is not tested. Then we create a new deployment with the signing image. And you can see the deployment is created successfully. And we can find the pod is running. Okay, the last demo is about container runtime detection and alert. In this video, first we create a Struts web service, and then we run a malicious command with remote code excuse vulnerabilities. Here is the remote commander. Then we back into the Cloud Security Center console. We can find the alerting on the host side and the network side. We can find the attack IP and URL and the post date. You can find the command line here. And then we switch to the handled page. Okay, we can find the malicious remote request is intercepted by our security center. Okay, that's all demo today. Thank you for watching.
Okay, cool. Can you hear me now? Okay, just now I got muted by myself. Okay, there any questions regarding the sessions? I have the speaker of auto scaling. Actually, he is in the group, and if you have any question, you can you can actually reach out to. You can add him in the group, or you can shoot your questions. I can help you to forward the questions to him. He's actually in the group and he can answer the questions for auto scaling. Auto scaling is a pretty important session, and it's pretty common use cases as well for Kubernetes. Okay, there is another question. Is there a PDF module that I can read for this training? Okay. We can certainly share the PDF materials later on. Yeah, so it's okay. Yeah, sure, we can share the PDF. But for the demos, right, there are a lot of demos in the sessions. You probably have to, click the playback and access to the demos. Demos we're not able to share on PDF, obviously. There is another question. Video recording. Okay, if you click on the right side of your screen if you're using PC version, or if you click the three dots on the right, on the top at the right, three dots, and you will able to see there is a live playback. Let me give you a screenshot right away. Okay, for those who actually don't have, let me give you a screenshot here, and you'll be able to find live playback. Okay, can you see the live playback on the right? Yes, you actually can click the live playback, and there are a lot of videos available, and there will be videos available for the sessions. Okay, and then on the mobile, if you are on mobile, you can click. Okay, it's not three dots on the. Okay, just not on the desktop. It's just on your right. Desktop is on your right. Just click Andreas. For desktop version, it's not three dots. It's just on the right side, the toolbar. There's one about live playback. I shared the screenshot I shared in the group chat is desktop version, and for mobile version, you can access through the three dots here. there's live playback. Hold on, let me share this in the screenshot. This is yep. Thanks for sharing. Yeah, and the screenshot I shared just now, this is for the mobile version. If you click the three dots, and you will find a playback button there as well. Okay, so this is there's another question here. Kindraivan, okay, your question is, if possible, please let us know more details on what will be tested on the exam besides auto-scaling security. Okay, cool. Yeah, I will let you know, because let me quickly post before we move on to the next session, let me quickly post what will be covered in the session. Hold on, give me a second. I do have the slides. I just posted on, it was mentioned in the CloudNative Day. We have the modules, right? All the modules available for this, all the modules applicable for this session, for this exam. Hold on, let me just quickly get the slides. And yeah. So let me open up the slides and then give you a screenshot about all the modules. Hold on, I know you guys quite. Okay. Okay, here are the 10 modules that hold on, just give me a second. Any other questions regarding security? I have my speaker available here as well. Please feel free to leave your questions here. Okay. Here are the 10 modules here that will be covered in the exam. So for those who are taking the exam tomorrow, remember some of the modules actually already covered in the CloudNative Day, and then we will not repeat majority of them, but we will probably also, today we actually redo a session for auto-scaling, because auto-scaling is extremely important. And tomorrow we will redo another session for multi-cloud as well, or hybrid cloud, multi-cloud. And then for those who are not covered, for example, application observability is not be covered today and tomorrow, and CI/CD won't be covered today and tomorrow as well. Microservices, CloudNative AI, all these sessions actually are covered in the CloudNative Day. So you probably can access to the CloudNative Day and find more details. Then for today, actually, we covered CloudNative security, auto-scaling, and the last session of the day is the migration application to Alibaba Cloud. Okay, then tomorrow we will cover hybrid cloud, multi-cloud, automation by Terraform, and serverless cluster. Okay. Sounds good. Any further questions, please feel free to let me know. And with that, let's continue the learning today. Any question? Okay, there is one more question here. A playback. Yeah. Okay, the playback. Okay, my dear, DS, can you help Echo, right, on the playback? Anyone can help Echo to find the playback? Please. Cool. So I believe the friends in the group chat will be able to help you find the playback. And without further ado, and if any questions on security, and I assure you security is a very important component as well in this exam. So please pay more attention on security. And if I have any question on security, please feel free to leave your questions in the in top group. So without further ado, let's start. Next session is about migrations. Migration is going to be a little bit complex, and it involves network, storage, etc. So your attention, please, on migration. And the speaker is Li Shan. I believe many of you are quite familiar with Li Shan.
Hello everyone, I'm Li Shan. I'm Senior Solution Architect, Lead Cloud Native Solution. Today we'll talk about migration applications to Alibaba Cloud. If the applications are containerized, that is easy to lift and shift. But when we migration applications, we also need planning Kubernetes cluster required resources, such as how many worker nodes we need, how many resources capacity we need, which network and storage is fitting for our requirements. So this topic will cover migration steps overview, cluster required Kubernetes planning, network planning guidance, storage planning guidance, checklist before production goes live. First of all, let's take a look migration steps. From our experience, migration application includes 5 steps. Step 1, cluster required resources creating and configuring. We should plan which type of Kubernetes cluster we will adoption, how many worker nodes we need, which region to provision the nodes, etc. Step 2, data migration, includes Docker image migration, database migration, and storage migration. In each part, we also provide tools help you to easily migrate. Step 3, application migration. Either will your CI/CD platform to make continued deploy to cloud, or use Valero, the tools which is provided by Alibaba Cloud, help your application migrate. It's detailed information you can get from the Git repository. Step 4, testing the application. Configure a test domain to make it can be accessed. Test the features of applications. Make sure major features can be worked, such as connected database, file storage, etc. Check application logs can be collection. Check cluster and application metrics can be monitoring and alerting. Step 5, switch traffic. Update DNS configuration to switch the traffic. If your application code includes URL, don't forget update code or configuration in applications to make sure the URL is right. Next, I will briefly introduce Docker image migration, database migration, and storage migration, and then I will deep dive cluster required resources planning. Docker image migration. Alibaba Cloud provides tools named Image Sensor, and we open source it. You could get it from this Git repository showing on screen. These tools be able to synchronize Docker image from Docker Hub, AWS ECR, and GCR to Alibaba Cloud Container Registry. If your application running on VM, firstly, you need to make your application to containerized. You can be done from capture VM image, convert to Docker image. If you want to change the Docker image, you could update the Docker file and build a new Docker image, and then push to Docker Container Registry. Data backup and restore to persistent volume. It can be done from backup volume, restore the volume on cloud, generate PV persistent volume. If your application provides a multi-access entry, such as /list for list page, /detail to display a detail page, you could define virtual service by Istio or configure layer 7 ingress to enable original network path can be accessed in the Kubernetes cluster. Database migration. Alibaba Cloud provides more than 20 services and tools cover OLTP, OLAP, NoSQL, database management pillars. Like we see, this is one of the solutions. If your data is strong Oracle features, you could migrate to PoloDB Oracle. If your database is weak Oracle features, you could migrate to MySQL or PostgreSQL. Some tables also can store in OSS. Analytics DB be able to analyze data which is on OSS and database. For OLTP and OLAP, we provide a large-scale storage and high-performance analytics ability. Storage migration. We provide online and offline data migrate to Alibaba Cloud. Offline migration. The scenario is for local IDC cannot connection to internet or bandwidth limitation. So we can via data transport, which is provided by Alibaba Cloud, that can achieve local data migrate to cloud. The data source supports NFS, NAS, HDFS, FastDFS, or CIFS, etc. For online migration, we provide a migration service. It can via network or list line migrate data to Alibaba Cloud OSS or NAS. The data source supports object storage or file storage like NAS. Above, we briefly introduced Docker image migration, database migration, storage migration. Next, let's deep dive to Kubernetes cluster required resources planning. Firstly, you should determine all applications will migrate to cloud or adopt a hybrid cloud strategy. If adopt a hybrid cloud strategy, which type of hybrid cloud strategy we will use? For example, a part of applications running on cloud, a part of applications running on IDC, and use CI/CD platform deploy applications to multi-cluster, use GTM manage the global traffic, or all applications migrate to cloud, but database keep running in IDC, or major applications running in IDC, but scale up to cloud. And next, select a suitable cluster, managed or dedicated or serverless cluster, or GPU bare metal cluster, or Windows or edge computing cluster. Calculate resources capacity. The principle is via stress testing to calculate how many capacity inconsistent and how many capacity will auto-scale to cover. Stress testing each microservice. Through stress testing, we will know the microservice maximum workloads, what kind of metrics is fitting for auto-scale, such as CPU or QPS or latency. Also need stress testing business module. Firstly, we should know the main link of this business module. So what is the main link? For example, an e-commerce platform in transaction part that provide add commodity to shopping cart, inventory calculation, order preview, lock-in inventory, assign order, etc., etc. So those features can achieve a business module. So through stress testing the business module, we should know the maximum scalability because we know the normal QPS plus how many modules you have. So we can calculate how many consistent nodes we need and how many nodes will auto-scale to cover. And we also will know what kinds of scalar is better. Cluster scalar or virtual node scalar. Cluster scalar means that we'll add more nodes to the cluster. Virtual node means scale pod running on ECI, Elastic Container Instance. For example, if we have 100 microservices, per microservice need 5 instances averagely. Each instance is 2 core 4 gigabit, and the redundancy is 10%. So the total capacity is 1,100 core and 2,200 gigabit. How can we select nodes? These have 4 steps to reference. First one, choose a suitable instance type according to application's character. Alibaba Cloud provides extensive instance type for your choice, such as general, computing optimized, memory optimized, etc. ECS instance with local SSD, or ECS experimental, etc., etc. Next, if you are creating dedicated cluster, the master node capacity according to how many worker nodes running. For example, if you have 1 to 5 worker nodes, the master node should be 4 core 8 gigabit. If we have 6 to 20 work nodes, the master node should be 4 core 16 gigabit. If we have 21 to 100 work nodes, the master node should be 8 core 32 gigabit. For worker nodes, how many capacity of worker nodes we could from previous mentioned the method to calculate. Do you remember from stress testing to get consistent capacity plus how many microservices we have? So if we calculate the capacity more than 1,000 core, we suggest to use EBM, ECS experimental as worker node. If less than 1,000 core, experience its single instance capacity as higher as you can. That will reduce worker nodes amount. Therefore, increase master schedule performance, increase resource utilization because remain fragment are less. Also reduce operation cost. Redundancy suggestion. Remain usable capacity can be running pods which are drifting from any ECS has been done. For example, if there have 10 pods running on an ECS, the redundancy instance is able to run the 10 pods in case the ECS has been done. Last one, don't forget, attach data disk to worker node. Because Docker image, system log, temp data will consumption data spaces. If do not have data disk, those files will store in system disk. That will make system disk broken cause overstore. But when you attach the data disk, ACK will automatically mount to specific folders to store those data. that will protect system disk broken. If in production environment, we suggest the system disk is 100 gigabit. Next, let's see network planning guidance. Alibaba Cloud Container Service provides two types of network plugin, Flannel and Terrain. Under the Terrain network, we also provide two types mode, like we see in the left side of Terrain network. That is a multi-VIP, or we said virtual IP mode. It can be achieved by WAF or IPv6. In the right side, that is exclusive mode. That means the port will directly connection to network, do not have any performance consumption. So how to choose them? There have some experience you could reference. If your application will use network policy, or your application need high network performance, or your application will use some special features such as shared VPC. So we suggest you should choose Terrain network. But if you just want to use network in Kubernetes cluster, do not have any specific demands, we suggest you should choose Flannel network because that is easy to use. Let's see the performance test in detail of each network mode. Orange color is ENI exclusive mode. Yellow color bar is ENI multi-VIP with IPv6 mode. The black color bar is the Flannel mode. So we can see ENI exclusive mode is Terrain network have a good result under UDP PPS. That means if your application is gaming or high performance computing, you should choose Terrain network. Let's see how to configure network in detail. If in Flannel network, when you create a Kubernetes cluster, you could define port and service CIDR, like you see the image on right side. The subnet mask of port CIDR determine how many ports can be hosted in a cluster. ECS instance type affects how many ports can be running in a node. That according to a port required resources. For example, an ECS instance type is a 4-core CPU. Each of your port required 1-core CPU. So that means in the ECS can run 4 ports or 3 ports. So how to select IP address per node like red box highlight that's relevant with the ECS instance type and the ports required resources capacity. If you select a large number of IP address per node, but your ECS just can schedule 4 ports, the IP will be waste. In Terrain network, node and port IP range defined by vSwitch. That means you should create a two-way switch. One is for node, another one is for port. How many IP can be assigned to port determined by ENI? ENI have exclusive mode and virtual IP mode. The assigned IP amount is different as well. An ECS instance can be binding multi-ENI. When you select an ECS instance, on the table will show how many ENI can be binding to the ECS. Next, let's see storage planning guidance. ACA supports all kinds of storage as Kubernetes persistent volume. Each storage is fitting for different scenarios. For example, Cloud Disk is suitable stateful app database. NAS is fitting for log shared data. OSS is good for media and genetic data. CPFS is suitable for HPC or deep learning. Local disk is good for database or Hadoop. So choose fitting storage for your applications. The red color box highlight means either you should know the notice or that are important features. For example, cloud disk is zone aware. That means the ECS and the cloud disk cannot cross zone. Let's imagine a situation. In a pod YAML file, define a PV. If the PV in zone A, that means the pod will be scheduled to zone A. But if zone A do not have the ECS instance, the pod schedule will be filled. Another like NAS support subdirectory mount. That means ACK will automatically create a subdirectory of NAS and automatically mount as pod created. The subdirectory is isolated. It will not affect other directory which is using for other applications. By the way, if you use NAS, we suggest you use version 3. OSS is fitting for read more and write less scenario. We provide the distribution cache acceleration ability. It be able to achieve 4 gigabit per second read speed. By default, ACK provide 5 storage class for cloud disk. Cloud disk includes SSD, eSSD efficiency. But notice the minimal value is 20 gigabit. So far, we talk about how to calculate resources capacity, how to select a network and storage. Next, let's see checklist before production goes live. Firstly, we should configure CPU, memory requests, and limits in a pod. That will avoid the error of over-scheduling pod on a node. Enable image security scan in ACA container registry. That protect your base images do not have secure risk. Configure logging, monitoring, and alerting. That allows you know your application's running status, microservice and cluster nodes are running well. Configure liveness and readiness. That make application can be accessed after it is truly running. Enable ECS auto-renewal. That avoid the application cannot be accessed because of ECS stop with expired date. Adjust SLB instance type and bandwidth. As the table on in red side shows the QPS and marks the connection of each SLB instance type, according to your application reality access situation to adjust the SLB instance type. At last, don't forget enable auto-scaling and configure auto-scaling, such as use HPA or cron HPA, use cluster autoscaler or virtual kubelet autoscaler, use CPU memory trigger scaler or through QPS latency trigger scaler. For autoscaler, both interface layer and service layer should be scaling together. Otherwise, if you just scale interface layer, it will be able to support much more workloads. But the server layer cannot support sufficient workloads. The service layer will become workloads bottleneck. Like we see the demonstration, there's 2 deployment pods. The access from Ingress Each access log can be stored in log service. HPA triggered by QPS metrics. For the service layer, the two deployment ports log stored in log service and application real-time latency can be awareness by ARMS. So the HPA can be triggered by latency from log service or ARMS. By the way, in ACK to achieve those external metrics very easy to do. Like we see the image in right side. Just define external metrics in HPA YAML file. This defines the latency if more than 5 seconds that will trigger HPA to scale up. Like I mentioned previously, config logging, monitoring, and alerting that allows you to know your application running status, microservice, and cluster nodes are running well. Ingress and application log stored in log service will NPD to awareness cluster event. All the events can be monitored in event center of log service. Application performance will ARMS or Prometheus to monitoring. There are some dashboards of log service. By default, log service provide more than 10 dashboards to allow you easily know your cluster and application's healthy status, such as Ingress dashboard that shows your application's PV, UV latency, which area has been accessed, your services, and so on. For Event Center, we'll be able to see what events has been happened in a cluster, such as pod eviction, pod starting failure, image pool failure, node disk space, insufficiency, etc. The monitoring service end-to-end workflow, like this demonstration shows. In monitoring level, enable cloud monitor to monitoring resources and SLB. For Ingress controller, we can via log service, ARMS Prometheus, and tracing to monitoring and analysis. For microservice gateway and each microservice, we could use ARMS or ARMS Prometheus to monitoring application metrics. In configuring level, for SLB, we should make sure SLB instance type is sufficient for workloads. We suggest SLB bandwidth upgrade to 5 gigabit. For Ingress controller, we suggest deploy a separate Ingress for internet and the intranet traffic. Configure CPU, memory requests, and the limits for pod. Enable tracing. For microservice gateway, we suggest isolate deploying. Also need configure CPU, memory requests, and the limits. Configure APM, application performance management, such as ARMS or other APM service. For each microservice, configure CPU, memory requests, and the limits. Enable APM. Configure database cache connection pool. Above, I deep dive the part of our suggestion that is migration application to Alibaba Cloud. Hope that is useful for you. Thank you for your attention.
Okay, cool. Thanks, Lishan. Lishan is based out of UK. So it's a bit too early for her to come up and address the questions, if any. So, any questions, by the way? I just now have posted CloudNative Day link in the group chat. And for those who would like to access to the CloudNative Day. To learn more about DevOps, you can get all the videos there through all the link I shared. Any questions for the questions for the exam, for the trainings? For those who are interested, who didn't receive the invite for exam, and you can, we still have a few seats available. So you can reach out to me or Darling and let us take a look and see whether we can fit into the exam. Okay? Cool. So if there's no further question, I will end the session today, and then I will see you all tomorrow for another session, 3 sessions training tomorrow morning. After the trainings, we will move forward to the exam. As I mentioned, the exam is not easy. So please be prepared. If you're not ready for the exam, you can take it next time. We will organize another exam in July as well, if possible. I mean, let's see if you guys are interested. Okay, and that's all for today. Thank you. Bye-bye.